hello to everyone. How are you today? Are you enjoying here at VivaTech? That's a yes. That's all. Over here. How are you today? Please give a great round shout, please. Oh, okay. At least there are a few ladies over here. So I can see hello and welcome to Sanofi's booth. Thank you very much for joining us for a very exciting sessions. I don't know if you had the chance to have a look around. Have you? Yes and no? Did you see our fantastic surprise over there? The McLaren Formula One fantastic car. And we have a great journey for you. We will start this afternoon by talking about digital ballroom twin. Very, very bizarre name, but very useful. We will talk about how you, Sanofi, are using AI technologies to adapt industrial assets, obviously, to planned or unplanned demand. So please welcome our exquisite guests, Pierre-Damien Martinet and also Jakob Harttung. Welcome to both of you. Very excited to do our session after preparing a lot. So before we dive into digital ballroom twin, you will tell us what it is. Let's first talk about the context of the concept that emerged. Tell us about that.
So hello Christina, hello everybody. So the context came back at the time just after the COVID. So we all remind the COVID. For the healthcare sector, it was a very something that we didn't anticipated. So for Sanofi, we came with the concept of how we can adapt very quickly our asset, our manufacturing asset, to be able to manufacture new medicine, new molecules much more quickly. And this is where the concept of modulus came. The principle is to be agile and flexible, to be able to change a product produced the day number 1 to another product the day number 2.
And we will discover more about modulus, who might seem yet a little bit strange as a name, but we will know more. Jakob, tell us, what is a digital ballroom twin, and even, let's say, a digital twin, because maybe people don't know.
Oh, I'm sure they know already. Hi, everyone. So a digital twin is very easily, it's a virtual replica, a mirror of a physical reality in a digital environment that you use to do simulation optimization in parallel to the physical reality. We use twins in different areas in Sanofi. We've got twins of manufacturing processes. We've got twins of equipment. In this case, a digital ballroom twin is really the twin of a whole production area that we specifically optimize and use to fit with the concept of modulus of modular and flexible manufacturing.
And probably as a teaser, some key features?
So we use it, as I said, to reconfigure the environment in order to simulate how we could produce something different, how we set up the manufacturing equipment to work on a different place. We also use it to look at flow across the reconfigured factory and how we optimize operations when we've changed what we're actually producing within the plant. Simulating all of that to make sure it works when we set it up.
So you start mentioning a few, let's say, features, innovative features, and also capabilities of this next generation manufacturing facility. Tell us more, Pierre-Damien.
So if I go into the detail, yes, so I missed that one, by the way. So when we say that it changed the game, because if you compare to the previous life, normally our assets, our manufacturing assets, are made for one molecule, for one vaccines. Here, the concept of modulus is that we can do in the same building, in the same area, up to 4 different products at the same time. And this is where the game changer is coming from.
I see. And how innovative exactly is a next generation manufacturing building compared to the current one that we know?
So I let the video at the same time just to show you. So that's important in the context of Sanofi launches. What is the launches? Sanofi has a unique portfolio in terms of new molecules, in terms of new medicines. We have up to 30 new molecules in the portfolio for the next 5 to 6 years. So the goal for us is to be sure that for the manufacturing asset, we are ready to do that. We are ready to, I will say, manufacture quickly to adapt to the environments. This is where the concept of modulus came from. And this is where, so you see the video here behind me, that we, I will say, inaugurate the factory back in September.
So I understand, Jakob, that what we just saw is the manufacturing asset created by Sanofi. What about the digital ambition of these buildings that we saw?
So digital is a very important part of these buildings. Modulus is not only our most modern and state-of-the-art manufacturing facility, it is also a state-of-the-art digital facility in the current network of Sanofi. We've pulled into Modulus everything that we do best in other factories across the network, leveraging from the experience of that in terms of standard systems, standard operating procedures, using analytics AI to optimize planning, manufacturing activities. But we also pulled in quite a few things that are specific to the concept of Modulus and making this our high-end factory. What we're doing typically is, as Pierre-Damien will explain a bit later, we can change what we are manufacturing within the facility. Normally, a manufacturing plant is relatively static, but as we move things around, we've had to optimize the infrastructure to support that. So the infrastructure in terms of network, in terms of security, cybersecurity is increasingly important in these kind of environments, and that is really completely reconfigured to support this new concept. In the same way, we have everything within the factory which is connected. We're capturing data real time for everything that is happening. We do that already in other factories, but since here we can reconfigure the factory, we need to have that dynamically assembled in order to still be able to use the capabilities. And then, of course, we'll get over to the Ballroom digital twin a bit later, which is one of the key innovations we've had. In the end, in case you haven't heard it before, one of our ambitions at Sanofi is to be the first biopharma company powered by AI at scale. Modulus is a great example of that, and also specifically focus on one of our other ambitions, which is to drastically reduce the time from new therapy discovery into patients actually receiving the medicine. And so we're putting digital into those capabilities.
And those are great ambition. And another ambition is that you're targeting to be carbon neutral by 2030, which is quite a challenge. So tell us, Pierre-Damien, what is the impact actually on environment of this facility?
So you're right. For Sanofi, the environmental aspect is a very important one. So the target is to be carbon neutral by 2030. That's our target. So for that new building that we just showed before, so we took since the beginning this environmental approach as a key important thing. So there are three main drivers. The first one is to be carbon neutral or close to carbon neutral. To do that, we have solar panel on top of the full building, so a large part of the solar panel. The second one is about the energy consumption. So we have a lot of sensors everywhere, and the building by itself is designed to reduce the consumption, like the house at home. That's the same principle. And finally, the goal is to have the low, I would say, waste treatment at the beginning. So we want to recycle as much as we can. And doing that, it helps us to target, I would say, the certification, the highest ambition for the certification in terms of environmental footprint. So that's the lead called, that's a US standard. And we submitted the dossier and we are waiting the answer for September this year. So we crossed the figure.
Wow, so I'm impressed. It's not only very efficient for the production, but it's also environmentally, let's say, friendly.
Correct.
That's great. So how many of these buildings, these facilities do you have around the world?
So that's a very good question. So Christina, so we have two of this kind of building in the world. So the first one is in France. Neuville-sur-Saône is north of Lyon. So that's considered as a brownfield, meaning that there was an existing site already in place. We leverage all the utilities and we build a new production asset. While in Singapore, it was considered as a greenfield. So 5 years ago, there was nothing, and we created the manufacturing building, but also the other building. I think we have a couple of pictures.
I was going to say, what does it look like?
So it looks like that part. So you see, this is a very huge building, big building, 200 meters by 80 meters in large. So that one is for the one in Neuville, and that one, this is the full campus in Singapore, where we see the manufacturing building, but also just in front, the QC part for the testing activity.
Very interesting. And Jakob, let me come back to the concept of digital twin. How can this innovative solution help a factory switch from one process, one product, let's say, to another in a record time? How does it work?
So, as I said, the twin is a replica and a mirror of the physical reality. In this case, the physical reality changes every time we reconfigure, so we need to maintain that live corresponding to that environment. What we do is we have a full model of what will be in the factory in the specific setup, and we can start evolving that and analyzing that. So even before actually the full building was completed, even before we put equipment in there, we had that model and could actually validate that we had the right setup, that the operators could work in the right way within that environment, and we could simulate changing over from one production to another. When I take one equipment, I move it over, we can do all of those kind of simulations. And so it enables us in all cases, before touching everything physical on the ground, to make sure it's going to work and going to be right first time. And then when we start executing, everything flows and it goes much faster. So setting up a change comes over something which took months before to days today.
So digital twin is used for everything, actually. It could be used for a patient, from a building, for plenty of things.
Digital twins is a very broad concept, but you optimize it for what is actually really important. One of the key elements of Modulus was being able to change production, so we optimized the digital twin for exactly that scenario and that capability in our case.
And do you... Yeah,
I wanted to add, Christina, if the people here want to showcase, so we have the booth in Sanofi over there. You can try to go to the digital twins. We have the famous glasses where you can go inside the building, navigate. So the team is waiting for you. Virtual reality. So the team is waiting for you just here in the corner.
That's
and you
great.
can actually experience it yourself, indeed.
Very interesting. What about the fact that once everything is completed, are you still using digital twins?
Of course we are, even more than before. We used the twin before it was building, but maybe shouldn't you shift? I think we have the next slide.
Sanofi inaugurated
Yeah, we'll get there.
groundbreaking vaccines and biomedicines production facility in France.
Just showing you what it looks like.
Fully AI-powered, Modulus features next-generation technology that can be reconfigured in days to address urgent and unplanned public healthcare needs. The Ballroom Twin is one of the Modulus AI-powered enablers to achieve a plant reconfiguration in less than 7 days. It's a living model of the shop floor, simulating setup of manufacturing lines with 3D representations. It enables defining, assessing, and confirming the plant reconfiguration scenario in virtual reality, allowing to be first time right in the execution. By helping to reduce launch cycle time and optimizing Modulus performance, the Ballroom Twin plays a key role in our journey to become the world's leading immunology company, leveraging AI at scale.
So, as we said, we used it while we were still constructing the facility. But it's being used constantly now. And it's a living twin of what is actually in the factory. So we use it today to be sure what is the exact configuration on the shop floor, what's the equipment, how are they connected. But every time we make a change in that configuration, because we start producing a new product, we will do that kind of simulation with the twin, simulating what the factory will look like once we've made the change, simulating the changeover in terms of flow of activities, and then reusing it again to the constant element where it is. So we used it before, we use it now, and we use it tomorrow, increasingly also. We'll get back to a bit more detail on that afterwards. And I just want you to see what it looks like to get a better feel of it.
And how does this technology create, let's say, strategic value for Sanofi's manufacturing production?
Well, already one of the key values is being able to produce multiple medicines and doing that faster and integrating new potential vaccines. So we've got higher agility and flexibility. We can produce things that we couldn't produce before because of the lead time of building a new factory. But overall, we're also having something where we can optimize production constantly. We can change things. We can change the layout. We can change the flow. We can change how we're actually operating things. And we can simulate that beforehand, looking within the twin, how will we operate tomorrow? Is it more efficient? And then apply it in the physical environment.
And when you say optimizing, what does it mean? I don't know if...
Optimizing things such as the time it takes to actually do a task within the facility, avoiding conflicts of things. If I want to change things over to 3 different equipments, I need to do that in the best possible order, otherwise I will have dependencies and it won't be working. If I need to optimize the operator's activity, if he has to go back and forth between different activities, then we're going to lose time in production. While we put in the right order and the right setup, we will have more optimized activities of each of the people within the factory.
And to complete what Jakob said, so we have seen on the previous slide, normally the time to reconfigure a kind of facility is probably more in months, 3 to 5 months. Here we are speaking about days, 7 to 10 days to reconfigure the facility. This is what is unique.
And I also have heard that competitors are building also this type of facilities. Is it true, or?
You take that one?
I can take this one. So, based on our knowledge, this is always the same story. Based on our knowledge today, we are not seeing the same kind of facility. You can see the kind of facility for one product, but the capacity to have on the same building 4 products built at the same time, manufactured at the same time, this is what we consider quite unique for Sanofi.
I see. And one probably last question, and we give the floor to you if you have questions. Let's talk about predictive capabilities for maintenance, data-driven process optimization. What about that? How we can improve the yield?
So it's something we do which is not directly connected to the twin as such. But as I said, we have integrated a fully connected factory in terms of all equipment, all operations, and all process elements. And so we have defined a standard element of how we optimize analytics in order to do predictive maintenance activities, predicting when we will have a breakdown, whether we can continue producing in the current state of operations, and therefore minimizing all of the activities that are not directly related to actually producing medicines within the facility.
Well, that's a very interesting, actually, facility. Yeah.
So we wanted maybe to conclude a little bit and give to more information. So what are the outcomes? You asked the question, Christina. So we try to summarize what we explained with Jakob since the beginning. So knowing the context of in pharma world, something are unplanned in advance, and this is important to react. This is where this unique concept arrived, to be agile and flexible to adapt to the demand that are planned or sometimes unplanned. That's number one. Number 2, we want to manage the changeover. This is where the digital part enters to the game with artificial intelligence, as explained by Jakob. So this is to help us to reconfigure much more easily the plants. Knowing that Sanofi portfolio is quite unique, with the 30-ish launches in the future, how we can adapt our ambition to be sure that the manufacturing assets around the world are quite ready. So Modulus is part of the answer. And at the end, we need to think about that there is patients that are waiting new treatments, new molecules. And this is where this building helps us to be right first time. Right first time means that we deliver the new doses, the new medicines, quicker to the patients that need this new treatment.
Yes, that's the final destination that is important.
Exactly.
Great. Congratulations. Great applause to you. I think, thank you. Do we have any questions in the audience? Yes. Don't hesitate to bring it very close, yeah? Thank you.
Hello.
Yeah.
I'd like to know if it's
a little louder.
Is it an in-house solution that you made? And did you rely on third parties?
So there's a lot of in-house, but there are a lot of things in this environment. Specifically the twin, a lot of the things are in-house because it's based on concept that we develop in terms of how we manage the equipment, how we manage automation. But there's a specific solution from Dassault Systèmes that we're also using to visualize and model some of the elements. Also, there are things that we are specifically adding to this. We've talked briefly about how we are using AI to optimize activities. One of the key areas we're focusing now on is how do we leverage AI to automatically find better configurations? How do we leverage AI to optimize the flow of activity when we set up different things? Which equipment do I put in first? Which order do I put in first? Which is the flow optimization. That's something where we're working on and doing these in-house. So it's a combination of elements. You can't just buy it, but we didn't build everything ourselves.
Another question? Yeah. Oh, yeah, please.
Hello. This is all great.
Bring it really close, sorry.
I wondered what has been one challenge that you faced or that you predict are facing with working with the digital twin?
I can start with one, Jakob, and you will complete. One of the first challenges was the mindset or the adoption of the tool. So we are using this kind of approach to build new plants since forever. So how you work with the team to embark them on the journey that, okay, it will not do like we used to do. There is a new tool with that, how we can use this tool. first, the reaction was, no, I don't need the tool, I know my job very well, so thank you. So this is where you have also to work in terms of working, how you adapt, how you embark the end user since the beginning. Because Jakob mentioned, there is the project, but after the project, there is the routine mode for the life. And this building will run for years. So how we are sure since day one, the adoption of this tool is in mind of the user that will use in project mode, but after also for the long time.
I think there's one question over here. Thank you.
What we saw here was typically the manufacturing area digital twin. Did you also do the modeling of the environment, as in the building controls and electrical distribution and protection?
No, we are not doing today this kind of modeling, even though we have a couple of examples. So if you take the environmental points that we have on the building just to check the quality of the air and everything, that part today we are capturing the data. In the future to be more predictive, to be sure that, yes, in terms of simulation, we can also do that for the simulation of the quality treatments.
Do we have other questions? Well, thank you very much. A great round of applause to you. Thank you.
Thank you, Christina.
Thank you. Thank you very much. And yes, indeed, we can come over there and tell us.
In the corner.
In the corner, you have a virtual reality glasses so that you can visit the plant.
So in the corner over there, you have the Lego mock-up of the facility to explain the principle. And after, the team is also bring you glasses to, I would say, project and immerse yourself in the building. So please come back here, and we are very pleased to welcome you.
So we'll definitely have just to join and visit also other places on the booth. Thank you very much to both again. Thank you. And ladies and gentlemen, don't hesitate also to visit our journey from research and development to the patient. And we have a next session in 20 minutes exactly. But you're more than welcome to visit the booth. There are plenty of innovations to discover. Thank you very much. Thank you.